Hello and thank you for observing this video. My name is Patrick Kajura. My interests are applied mathematics. Today we are going to be looking at second order differential equations, ODEs, homogeneous ones, which are very nice and simple equations to work with, and they're very interesting. They arise in many topics, many applied topics such as waves and other such interesting things. So that's second order ODEs, ordinary differential equations, that are homogeneous. That's what we shall be looking at today. As I mentioned, my name is Patrick Kajura. You can find more of my work and materials by Google searching TIOKRS, the interest of knowledge and research in science. And also there might be a link underneath this video to the website, which has my monthly magazine, Discourse on Science. And I'm probably going to be releasing a book not too long from now, probably before around about 2013, called Topics in Applied Mathematics. So moving on to what our topic is on today, second order linear ordinary differential equations that are homogeneous. First we'll write the standard form at which they may appear, which is this. So it's ordinary as y is only a function of x, and it's homogeneous as the right hand side is equal to 0. This is the standard form. A, b, and c are constants. So you've got dy squared dx squared dy dx and y. So our first thing is we're going to assume that one solution to the equation is a nice simple form of something similar to this. Something similar to this. Let me write it in the board. Something similar to this. Y is equal to a times e to the px. That's y is equal to a times and this is our first assumption that will hopefully help us to solve this equation. Y is equal to a constant a times e to the p to the x, which let's rewrite that at the top here. Y is equal to a times e to the px. If we differentiate that, actually also for the purpose of simplicity, let's say it's equal to s. So there we've got s. If we differentiate that, you get the p comes down and it multiplies by that. So we get p e to the px is equal to ps. If we differentiate that again, we get p squared times e to the px equal to p squared s. So as you can see, we have these equations. We have these equations for the y, the derivative of y. Let me write that here so it's nicer and clearer. Is equal to p a e to the px, which is equal to ps, and then the second derivative is equal to p squared a to the e to the px, which is equal to p squared s. So now our next decision we're going to make in order to solve this second order differential equation is to plug these values into this equation. So I'm going to leave these constants there, these expressions there. We're going to put this into the equation. So we've got a times the second derivative dy dx squared. So we'll put this and plug it in there. That will give us a times p squared s. Then we'll get this from that plus b times ps plus c times s is equal to 0. We can cross out the s and we have a nice quadratic equation of p, which solution will give you the solution to our differential equation by plugging it back into this original equation. There. Now we can look at a nice example. When we look at an example when a is equal to 1, a is equal to 1, b is equal to 1, and c is equal to minus 6. That will give us a d squared y, no, sorry, not a. That will give us dy squared dx by dx squared plus dy dx minus 6y is equal to 0. So we know that we're going to have to solve a quadratic form, solve a quadratic equation for this to solve it, which will be of this form. So we plug in our a's, our b's, our c's, and we get p squared plus p minus 6 is equal to 0. You don't have to apply the quadratic equation, you can just factorize nicely, which is 3p plus 3 p minus 2 equal to 0. So therefore p is equal to minus 3 or is equal to 2. And we've got two answers, so we now plug that into our function, and the solution is this: a e to the minus 3x plus b e to the 2x. And that's the solution to this differential equation there. And that's it. That's how you solve the second order homogeneous differential equation. Thank you for watching this video. I hope you enjoyed it. I hope it gave you a good brief understanding, insight into second order differential equations. Please may you visit my website by Google searching TIOKRS and see what other various materials I've got. Shall be uploading other interesting videos. I'll be going deeper into the study of differential equations, and we'll also look at the applications such as waves, oscillations, and eigenvalue problems for frequency. Thank you for your time.